Everything that I show you is totally accessible. You don't have to be an expert. You don't have to be an LLM guru. You don't need special tools. You just need essentially a distributed cloud subscription to deploy these LLM workloads and models. And you can even get away without a GPU. So you can do it with a CPU if performance isn't a major issue for you.
Wow.
There will be some limitations around. So if you're not familiar with the sizes, so let's take, for example, Ollama. So Ollama is an engine that has a couple of tools built in, several different models, but it's all based off of Llama, which was, I think Meta started Llama.
Yep.
So it's all the large language learning models around Meta. There's several other models that can run within the Ollama construct. So like depending if you're doing coding or if you're doing just chat bots or if you're looking for like creative writing type things. I know some people, if you watch the Reddits, they're using it for their D&D. So their Dungeons and Dragons stuff. So they're using it for character generation, for scenario generation and things like that. And they basically just use it to like generate a whole backstory for characters.
Wow.
So different models have different strengths. There are also performance evaluations of the different models. And there's also two big classifications that you'll see within the models, which is the easiest way to explain it is there's safe for work models and there's not safe for work models.
Okay.
The not safe for work models but are not filtered for illegal type content. How do I build a neutrino bomb? How do those sorts of things that are generally filtered out and are semi concerns, for some of the models that can go a little bonkers in their training. Mm-hmm. Where they'll go through and kind of pull a lot of that stuff out. So depending on the models, you get different interactions. I'll start from scratch here, and we'll just go to the Ollama top level page. So to get started with Ollama, you can just go here, download the code, run it. There's you can run it on Mac OS, you can run on Linux, there's even Windows, so you can run Ollama anywhere. With distributed cloud, we focus on not required, but it makes it easy to run it in containers. So there is a official Ollama container. An important piece of that is Open Web UI. So Open Web UI is pre-built UI. If you've used ChatGPT or other LLMs, basically the same interface, right? So it's pre-built for you. It automatically ties into Ollama. It supports the models that you can get for chat, for image generation, for all the things that we just talked about. So it kind of highlights the features. I'm not selling it, but this is kind of the things that you can do with it.
Right. Yeah.
The amazing thing about this specific scenario is they have pre-built customized templates that you can use with just traditional kubectl to deploy Open Web UI with Ollama. And then you just go and you choose the models inside the console that you want available to use for whatever you're going to use it for. So if I look at, for example, installation here, pretty simple, very easily accessible. If I want to deploy Ollama with Open Web UI using Customize, if I don't have a GPU and I want to use a CPU only, is this not visible? You need me to blow it up some?
Yeah, if you could blow it up a little bit, that'd be great. That's great.
And I'll share these URLs and stuff with you too, just so you can have them.
Oh yeah.
But if I don't have a CPU, then I just come in here, kubectl apply -f and base. If I do have a GPU, then just the top level. I've basically downloaded the repo. I've got the folder that has all of the things that I would need in here. And if you look at the customization, it's just pointing to all of those files.
Okay.
All I need to do to deploy this is that single command. If I have a GPU, really the only difference is it allows me to utilize the GPU. That's really the only difference between this stateful set patch and this stateful set. So I'm identifying all of my CPU requirements, my RAM requirements, my storage requirements, and that's it. But I don't see a GPU. So if I have a GPU, it applies this. So by default, I can deploy this to any AppStack deployment that does not have a GPU. If I have a GPU, even better.
So even just a little nook running in my basement.
Yep. Now, there's requirements around those models. So that's where, if we jump back over to Ollama, so let's look at the models real quick. And let's say I've been using Mixtral to good success lately. So there's several different models. There's the 7 billion parameter, 13 billion parameter, 70 billion parameter, whatever. Each of those have different storage requirements. So you need to make sure, like, if we're going to go the 8 by 22 billion, then we have to be able to support 80 gigs of storage, and then consider all of the vector database and other resources required to actually process against that database. So if I'm CPU only, I can do it, but I'm going to sit there looking at it loading for quite a bit of time. Usually what I notice with these models is that the first interaction takes a little bit of time for indexing and vectoring and that sort of thing. And then afterwards, the communication is a lot quicker.
Even with the GPU, the indexing is still...
A little bit, yeah.
Okay.
Because some of the GPUs, especially in like the cloud environments, we're not deploying with like 10 GPUs. We didn't take all of the, Bitcoin miners and throw them into the cloud. So you've got a ton of GPU available to these instances. You've essentially got a computer with a single GPU per node, and you can use it, and it does accelerate performance, but it is what it is. The GPU that I'm using in my model right now is the Tesla T4, which isn't bad. It's in conversations I've had, it's seen as like an entry level AI type GPU. There's some pretty cool stuff that's coming out of like Grok, and I've seen talk about some RISC-based GPUs out of China that are supposedly pretty good, but I haven't seen them in action yet. But this, you can run this on a NUC as long as you have the storage and resources available. There's another chart that you can find that talks about RAM requirements. So, I think the 13 billion parameter generally wants 64 gigs of RAM.
Okay.
So it jumps pretty high. Now, 7 billion is perfectly fine, the 7B models. So like if we come over here and we look at Mistral, which is sort of the basis of Mixtral, it's got this 7B model, which is 4.1 gigs. Perfectly fine. Works pretty decent. Now, if I want to run this in the deployed model, then I have to come over here into my pre-deployed scenario. Actually, I just deleted it. So let's fix that real quick, because I was gonna show you how to do that. So you saw I got the error pop up because it's actually gone right now. So if this is visible, you can see I've just deleted everything. So let's come through here. We don't have to customize anything, but we will, just to kind of take a look. So let's look at web services. We don't really need to touch anything. We don't need to give it additional storage for, the web interface. But if I were to redesign this to utilize distributed clouds infrastructure, I would set it up so that the Open Web UI web front end runs in the regional edges. So I've got that. And then it accesses the Ollama backend across the vCates network, across our fabric. And that can run in any number of AppStack instances anywhere we want. So just to kind of check that, Ollama service, not really too much. The standard is it exposes that service on 11.434. I can also access this as an API endpoint. So that's kind of the easy part of that makes this as accessible, is that Open Web UI already integrates into it as that API endpoint
cleanly.
But when you look at like guidance on, I'm going to do a curl to the API, here's the model, here's my query, and it responds back. Open Web UI already does all that for you, so you don't have to build a front end for it. You can still use the API, no problem, but it just kind of makes it a lot easier, so you're not plugging it directly in. The important part in this model, again, this is just straight from Open Web UI, is looking at the stateful set. I'm only going to deploy one replica. I could deploy 3 if I wanted because I have a 3-node cluster. I don't need that. I can look at the CPU and memory and bump that up if I wanted to. The nodes that I'm using only have 32 gigs of RAM, so that's going to be the limitation that I'm stuck with. Is the models that require sub 32 gigs of RAM is going to be my current limitation. I could go with a much more expensive instance type, but we'll just stick with this now so F5 doesn't yell at me.
Important.
Yeah. So the only other thing that you might want to change is like the storage size. Okay. Now, important here is that when I built the nodes, I only set the local storage to 100 gigs. So I don't want to go over that because the nodes don't have more than 100 gigs available. I don't want to steal all the resources from the local system. So I'm just going to leave this at 50 gigs for now. Yes, this is going to stand up a new deployment of Ollama
and
as a stateful set. Is going to deploy the Ollama web services or services. It's going to deploy Open Web UI and have everything be directly integrated so that I don't really have to do or know anything about what I'm doing. And then I'll have an LLM that does not have any models loaded yet. And then that'll just be the next step. So
nice.
Fingers crossed. Everything's happy. There we go. There. Didn't want to jinx it.
Yay.
I've got my K9S over here, which you probably won't be able to see in the recording, kind of telling me where things are at. So I can see my containers are creating.
Oh, that's handy. You have that hooked up for your CE.
Yep. So, all right. So now all of my services are running. If I jump back over to distributed cloud, I already had my load balancer and my origin pool set up. I don't know if those are things that you care to see, but I'll just kind of highlight them real quick. So if we look at, actually, I'll do it all from the same distributed app location. If we look at origin pools, I've got my Open Web UI. This is pointing to my AppStack site. Okay. It's pointing to this Kubernetes service on the AppStack site. All of that's fine. If we look at my load balancer, then we've got my Open Web UI load balancer. This also has, and this I think is kind of important where a lot of LLMs need some help, is because we have the full web, we've got the web application and API protection, I can not only apply a WAF to the chat side of the LLM, I can also apply bot protection, obviously, to login and those sorts of things. But I can also apply API protection. So I can do an API discovery, discover the schema around what's happening. Because I deleted it, I don't know if it will have disappeared, but it actually populates pretty well if we're looking at this specific app. Let's come over to security and look at API endpoints. So you can see it's discovering all of these different things that are processing across the API portion of the LLM. So we can see like, oh, so there's a potential for credit cards within the tags or other options that we can create security policies around. So this is where you can do things like add data guard protection to PII type data to say, especially if I'm using like an uncensored model and say, hey, how would I generate social security numbers, or how would I generate credit card numbers? And can you make sure that we're not allowing somebody to do that on this system? So it comes in pretty handy to be able to apply security to those endpoints.
Oh yeah. Data guards.
But I can also,
fantastic.
I can also look at all the health. So looking at, requests, I haven't actually hit it in the last 5 minutes because we were redeploying. But if we come back over to here, I'm going to be logged out because it's a new deployment, so I don't even have an account yet. So let's create an account. Boom, there we go. So now I've got an LLM running in distributed cloud with very minimal effort. I didn't even really have to do anything. Again, I said that there's no model here.
Yeah.
So let's go ahead and deploy a model. So we can come in here, come down to models. And let's say we're going to go ahead and just use the Mistral 7B, which is one of the defaults that it shows down here. We don't need the full strings. Let's do Mistral 7B. It'll take a minute to download that model, and then we're ready to start chatting. And so let me give it something sort of off the cuff that might not be a normal conversation. I'll give it a coding question. I'll say, I need to write a load generation tool to test NAS performance. Can you help me with this?
That was pretty off the cuff, man. Man, I haven't needed such a tool in a long time.
Yeah, but I mean, it's I had this conversation today, so it was fresh in my mind.
Look at that go.
So, yeah, so you can see it's pretty quick, right? Now I can say, I want to write this in Node.js. What would the application? There you go.
Wow.
So this one isn't designed for code, so it's not immediately like offering up code, but it is giving me like things to think about, proper processes, things like that. Let's say, what do you know about Spider-Man?
Peter Parker. Stan Lee. Oh. They went to the comic. Nice.
Yeah.
Okay. That's pretty amazing, man. Holy cow. And that
so if Spider-Man fought Superman, who would win?
It's got to be Superman. I mean, it has to be.
Yeah. So, I mean, but it's doing a pretty good job. The performance is pretty good. This is running on Distributed Cloud AppStack. I almost had to do nothing to deploy this to start testing out models.
Wow.
And then the beauty is I can start going in and doing additional changes to the platform. So like if I wanted to come in and if I wanted to come in and change up like the vector database on the back end, I can very easily come in and look at the stateful set and say, all right, well, this stateful set is using this. I want to add in a new stateful set that integrates the Chroma DB for vector, which now will act as a proxy for the database. And then I can just come back over to my open web UI, check my settings, and I can modify the endpoints that it communicates with. So instead of saying, hey, go directly to the Ollama service, go to the Chroma DB endpoint, which is filtering that service so we can do some additional testing.
Wow.
Yeah, so let's look at, let's see, we want to do some coding. So CodeGemma is pretty popular. Gemma's pretty popular. This is from Google DeepMind. But if they're built for a specific purpose, that 7 billion is pretty. So come in here, add a new model. Another interesting thing is you can now access this platform because I've given you access to it. But since I was the first user that created, I also have to, by default, approve new users to the platform, or you can turn that off. So you can allow other people access into the system. And because it's like a local LLM, I also have the ability to access their conversations and download those conversations.
Nice.
So it's like, I want to see what Aubrey's talking to my LLM about, see what's going on there. But it's pretty easy to add additional models to it. And the only thing that you really have to change is there's the drop down up here that says, hey, so see, we've downloaded CodeGemma now. So, so I can say, generate code in Golang for a CLI tool to load test NAS performance.
Wow.
Now, I don't know if this code's any good at all, but
right.
It definitely gives you the structure and some things. You can say, all right, well, it's got a tool, replace the URL variable. Let's say no. Let's say I want to pass.
It's not PHP.
Well, I want to pass the URL as an argument. So now we can come in here and we can see, all right, now it's going to look for arguments. It's going to tell me how to use it in the usage there. And then there you go.
Nice. That's really cool. Okay. Well,
so,
the next phase for me is I want to actually try this on my little Nook,
Yeah. I mean, it's pretty simple. You can see, everything's happy, but we can come over and we can look in the console and we can see all of my requests coming in. So we can see like I'm hitting the chat API. We can see the different pieces where I'm uploading the models. So all of that's happy. We can look if anything were to flag within. I'm not going to be hitting it with malicious user because I've got everything kind of protected. But we can see if there's any sort of security analytics. Right now, I think I'm just monitoring. I'm not blocking anything.
Right.
But we can see that, this was a SQL type injection attack. But this is also can be confusing because this is from the code in the response.
Interesting.
So if we go back here and we look at sleep time, that's what flagged the SQL injection.
So, well, that definitely speaks to visibility.
Yeah.
That's nice. Okay.
So, and that's not even the API endpoints. And then we can look here and see.
Is there API visibility already for this? That's.
Yep. I don't have a definition imported, so I'd have to wait until everything's fully discovered. But then I can also download that spec and use that as my definition for my LLM. But I can see where there's email addresses because I've registered on the site. So there is my email address was sent. It's discovered credit card numbers in the API tags. So we could look at adding some security around that. There wasn't actually a credit card number. It's just a regular expression that kind of matched it. I mean, that's all there is to it to get a simple LLM with a pre-built package up and running.
Okay.
I'll share this URL with you so you can do with it as you please.
Yep. I'll put it in the video and share it out to the community so they can tinker with it also.